Hello, welcome back to Mr. Farina's good old algebra class. Today we will continue with multiplying polynomials. But our main focus will be on special products. The first special product we deal with is squaring a binomial. The second special product we work with is a sum and difference problem. Now, there's two things to keep in mind when we're doing this lesson. First, what we're going to learn today is shortcuts. Okay, but one thing is, you do not have to use it. You could always do it the long way if you don't understand the shortcut. Second is, this is very important for next week when we factor. Okay. Recognizing patterns and how the shortcuts work help with reverse multiplying, which is what we consider factoring. So, although you don't have to use the shortcuts, it is good to try and learn them so that you can make factoring easy. So let's look at our first. Special product, and that is squaring a binomial. Basically, if you think about it, when we square any term, say 3 squared, we know 3 squared is 9, but why is that? That's because 3 times 3 is equal to 9. So when we take the binomial x plus 3 and square, one important thing is the non-shortcut way to do this would be to actually write the two bases out and multiply them together like we did in yesterday's lesson. So if I were to take this binomial times a binomial, which is the binomial squared, I can distribute this first x to the x plus 3. Then I can pull out this 3 and distribute it to the x plus 3. When I do my distributions, x squared plus 3x plus 3x plus 9. When I combine those like terms in the middle, I would get x squared plus 6x plus 9. Now, we did mention up above that there are shortcuts that we can take with this. And trying to recognize this helps out. And remember, you can only do this when you square a binomial. If I look at my first term here, x squared, that is just taking the first term of the binomial and squaring it. If I look at the last term, okay, the 3, I'm basically pulling that 3 out and squaring it. Now, how do I get this middle term? Well, if I multiply the two terms together, 3 and x, I would get 3x. Now think about it. What could I do to that 3x in order to get 6x? Well, that's pretty easy. If I double that, 2 times 3x, I would get 6x. So the easy way to square a binomial is basically square the first term, square the last term, then you are basically going to multiply the two terms together and then double that. Now, one thing you'll notice, no matter whether you're squaring no matter what, when you square a binomial, this last term will always be positive. The sign in front of the middle term will always be the same as the sign inside. Okay? Since this is addition inside, this would be plus. Now, let's look at the second example right away. Okay, if I was to do this the long way, I would have to write this out as 2x minus 7 times 2x minus 7. So I go ahead, I do my distributions. 2x times 2x, 4x squared. 2x times negative 7, negative 14x. Then, negative 7 times 2x, negative 14x. And negative 7 times negative 7 is positive 49. And now, when I combine like terms inside, 4x squared minus 28x plus 49 would be what we get when we square this binomial. Now, let's take a look at how that shortcut works again. Okay, if I were to take the first term, 2x, and square it, that's going to be my first term. I'm going to take that last term, negative 7, and I'm going to square it. Now, I'm going to basically, since this is a minus sign, I know my middle term is going to be negative, and I'm going to basically multiply 2x times 7 to get 14x, and I'm going to double that 14x. And now, 2 to the second is 4, x to the second, minus 2 times 14x is 28x, and negative 7 squared is positive 49. So, if you look at this just real quickly, all you're going to do is raise the first term to the second, square the last term, which is positive 49, multiply the middle numbers, double it, minus 28x. Okay, so that is our first special product, and that is basically squaring a binomial. Now, if I look down below, we have another special product. These examples, if you look at them, we have a binomial times a binomial. Okay, with a binomial times a binomial, we know we can pull out the first term and distribute it to each of the other two polynomials, or terms, and pull out the second term and distribute it to the second polynomial. Now, if I go ahead and I look at this problem, I see that this term has 6x and a 5. This term has a 6x and a 5. But when I look at what they're linked by inside their quantities, I have a negative and a positive. What we call this type of problem is this is a sum and difference problem. In a sum and difference problem, the terms are the same, but the only difference is because I have subtraction in one and addition in the other. Now let's see what happens here. If I just take any binomial and I say, okay, here's a sum and difference problem here. A plus b, a minus b. When I multiply the first two terms, I would get a squared. If I multiply first and last term, I would get minus ab. So a squared minus ab plus ab. Now that would be ba, but multiplication is commutative, so it doesn't matter about the order, so I'll keep it in alphabetical order. And b times negative b is minus b squared. A special property about these sum and difference problems is when you go to combine like terms, in the middle you'll always have one positive term, one positive term, one negative term, and when you combine those, they add up to 0, which means these basically eliminate each other, and I would be left with a squared minus b squared. So even if I come over here, notice again, first and last terms are the same, but one is subtraction, one's addition. So when I go to multiply this out, 6x times 6x, 36x squared, 6x times 5, plus 30x, negative 5 times 6x is minus 30x, and negative 5 times 5 is minus 25. Notice what happens here. Those two middle terms cancel out, and I'm left with 36x squared minus 25. So if you notice, the middle terms in a sum and difference problem will always eliminate, leaving you with the first term squared and the last term squared. And that's how we approach a sum and difference problem. We basically we square the first term squared minus the second term squared. And this can only be done if the first and last terms are the same. One pair is linked by addition, the other pair is linked by subtraction. So, if we look at the next example here, 3x plus 1, 3x minus 1. This is a sum and difference problem. All I have to do here is take the first term, square it, subtract the second term, and square it. And what would I get here? Well, 3 to the second is 9, x squared, 1 to the second is 1, minus 1. And we are done. Now, if you don't know when you can use these shortcuts, and when you cannot use these shortcuts, it is best to just go ahead and multiply them the way you see them. And that is today's lesson. Therefore, the extra practice is your job in order for you to complete this homework assignment. Have a good night.